So let's do some example problems. So this is an example problem, and I know that it's the SSA category because I'm given beta and I'm giving the side opposite. So I know that, and I'm given a second side. So this here is automatically um, SSA. And so that's how I could tell there. And so if I'm looking at that, now I have to decide what it is that I'm going to have 0 triangles, 1 triangle, or 2 triangles. And what we have here is if I'm given this, and I just drew this out on here, that you're going to have a couple of cases. It is going to be the 2 triangle case because I already wrote it out on there. And so here is the actual triangle. This here is going to be the angle that's given on all of them. So this angle 43, that's this one right here. So that's going to be 43. That's going to be 43. That is going to be 43. And then here, this is the side opposite. So we know that this one here is going to be 15 centimeters. This one is also going to be 15 centimeters. And this one here is going to be also 15 centimeters. And then the adjacent side, it's 17. So I'm just going to label this one here as the adjacent side. Now, of course, I could have used this as the adjacent side as well, but I could see it better on here. So this here is going to be 17 centimeters. And this one here is also going to be 17 centimeters. Okay. So I know that when I'm looking at these, I could figure out a little bit of the information. The main thing that I need to find out is this. What is the height going to be? The height is going to be well, it's going to be a straight line going and connecting to the other side, and it's going to be the shortest distance. So let's go back to the GeoGebra part and see if we could see it visually. So I know that the opposite side was going to be 15. So I'm just going to put down 15 there. And I also know that the adjacent side is 17. Okay, good. The angle that's given to us is 43, so I'm going to change that to 43. And so this is what we have, and that works out perfectly. So if I look at this, I need to figure out what the height is and see if it actually falls in there. My visual, I could see it, but what if I didn't have that visual there? And so I need to solve the height. And if I notice the height is going to be 11.59, the height is the distance from the vertex up here going straight, making a right angle and making a right triangle here. And so then I need to compare the opposite side with the height as well as with the adjacent side. But you might be asking, I don't have a computer to put this in, so how am I going to figure out the height? Well, the height is given from h is equal to the adjacent side sine of the angle. Now, do you have to memorize it? No, because you guys already know how to do SOHCAHTOA. So let's go back and see how do we do it with SOHCAHTOA. So looking at this here, I know that the angle is going to be 43, and this here is going to be my h right there. I'm going to ignore this side and that side for right now. I'm just going to say this is going to be, I just want this right triangle that I need to figure this out. So I am going to change the right, oops, I did too much there. I am going to change the right angle there, and I'm going to put it there because that's the angle. I mean, it doesn't really matter, but that's the triangle that I actually want to see. I want to see this right triangle right there. Okay. So what do we do? So in order to do that, it's going to be opposite. So I know I'm going to use SOHCAHTOA for a right triangle. So I'm going to do the sine of 43 is going to be the opposite, h over the hypotenuse, which is in this case the adjacent side. And so we get this. And then we put this over 1, do the cross multiplication. And so I end up with h is equal to the adjacent side multiplied by the sine of the angle. And that is the formula we saw on the other page on there. And so when we did that over here, we saw that when you calculate this, then you're going to get the 11.59. So I know that this here is going to be h is going to be 11.59 centimeters. So that's what we're going to compare it. So if I know that the height, this one here is the biggest one, is going to be well, the shortest distance, not the biggest one. The shortest distance is going to be 11.59. it's good. It forms a triangle because the opposite side is 15. And so, but the opposite side is smaller than 17. So what do we have right here? We have that H is smaller than the opposite side, but the opposite side is smaller than the adjacent side. When this happens, when the opposite side is in between the adjacent and the height, then we know that we have two triangles, and we are going to have solve two solutions for the sides on there. So let's look and see what happens in the GeoGebra here. How do we know that? Well, that means that this here is going to form on one side. I am going to be able to touch the third side by on the right of the height. So that's what it's going to form that big triangle. So if I go back on this one, that's the one that I'm talking about. I'm talking about this triangle. And this triangle has both of them on top of each other. So this one here is the acute triangle that we're talking about there. And then what happens if it's not on this side, but it's to the left of the height? It also touches the third side over here. So I am going to move this one here. And now the triangle that I'm talking about is this obtuse triangle that when I look at it, it's this triangle. So this is the acute triangle separated. And then this here is the this is the acute triangle separated. This is the obtuse triangle separated. This is one on top of the other. And so this is what we're going to look at there. So now what information do we have? So we know that if I look at this 17 is your C, so this is going to be your gamma. But this is also 17, and this side, this angle opposite is also going to be gamma, but these are not the same size. So we are going to call this gamma prime. And then this side here, the only other two things that we have is A and alpha. So this side is A, so therefore this side is going to be A prime, and then this one here is alpha, and this side, this angle here is going to be alpha prime. So in order to solve a triangle, we have to find all the sides and all the angles. Well, some of it is already done for us, right? So when we look at it, we already have that we are given the 43. That did not change. Oops, don't know what happened there. These screens are kind of touchy there. Okay, so we know that we have this angle here, that's 43. That's not going to change in any of the two triangles. That they're sharing that. They're also sharing C, which is going to be 17 centimeters. That is also there. And they're also sharing the side opposite, which is going to be 15 centimeters. We are good there. The thing here is that we are going to get an A prime, and we're going to have to find an alpha prime, and we're going to have to find a gamma prime, as well as an A, an alpha, and a gamma. So how are we going to do that? Well, we're going to use the law of sines. So that's not going to go away. We're still going to do the law of sines there. And so the law of sines says that we're going to take it, and we are going to do the sine of 43 over 15 is equal to the sine of, we're going to do the gamma over 17. So we are going to solve the acute triangle first. That's the easiest way to do it. And that's what you should do first, is always the acute angle. And so when we do this and we calculate it, we do the cross on there, and we end up having that we're going to have 15 sine of gamma is going to be 17 sine of 43. And so sine of gamma is going to be 17 sine of 43. And then we're going to get from the sine inverse. So we're going to do this because we need to get it by itself. We're going to do the sine inverse on this side. And so we are going to do the sine inverse on that one as well. And so what we end up with here is going to be gamma. Just be really sensitive today. Gamma is going to be sine inverse of 17 um, sine of 43 degrees. So we're going to put that in the calculator. And so we're going to put that here. We are in degrees, so we are going to do trig sine inverse of 17 times trig sine of 43. And hit enter. And we get, is it on there? I think, oh, because this is bigger, right? So if we go back on there, I forgot to divide it by, if we go back there, I forgot to divide this because I forgot the 15. I forgot to divide this by 15. And then this here's 15. And that's 15. That means that it gave me an error because it was greater than 1. So we could go back up there and then hit enter. And then we're going to put that all there. Very good. And then we are going to divide it by 15, get that answer. And that's what we have there. Now, what we're going to do is we're going to store it. So we're going to do, if you notice right above the bars, we're going to do control store. And we're going to store that answer. And that is my gamma. I'm just going to store it in C for right now. And then hit enter. So I know that C is going to have the 50 on there. Now, if I know that that one there, if I know that this angle, if I know that this here is 50, then I could find alpha really easily by doing the calculation. So I know that I am going to take C, add it to 43, and I am going to do 180 minus this. And that gives me my answer for alpha. So now I know what alpha is there. And then how am I going to figure out the other two angles on the other side? So this is where this is going to be in, this is the reason why I did the double triangle and embedded in one or the other. So I'm going to get rid of this because we don't need it. And so what you're going to know here is this. So if I look at this, I know that this is 15 and they're both 15. So this side right here is this side right there. And this side right here is this side right there. So these are both 15. That's the same thing that when I was going over here, that's this side right here, whether I'm going here or whether I'm going there. It's still the same side. So this here inside, what forms here is an isosceles triangle. So if I go back here, this in here is an isosceles triangle. And so I know that if I know this angle right here, if I know this angle right there, oh my goodness, if I know this angle, let me hit escape a few times. If I know this angle right here, then I definitely know this angle right there. And so if this here is gamma, then this is also gamma. And so because this side and this side are congruent. Now, there is a relationship then right here. So this relationship is that it forms a straight angle. So whatever this is has to add up to 180 from here. So all I do is I take gamma and I say it's going to be 180 degrees. So my gamma prime is going to be 180 degrees minus the regular gamma because they form a straight angle. And so that's the easiest way to figure that out. So if we go back to here, I know that I am going to take 180 and subtract it from my C. And so I end up with 129. And then, so this is my third angle. So I am going to then store um, actually, I should have stored this angle over here. Let's see. I'm going to do that. And I'm going to take this and enter it. And I am going to store that for A, for my alpha. So I know that's my alpha. And then I'm going to do that same thing again, 180 minus C. That's going to give me the 129. And then I am going to add that to the 43. And that's going to give me my other angle. So when I add those and I subtract that from 180, oops, take the answer, 180 minus, that's going to give me my other angle. So that's what I found out. So let's fill in the chart that I have there. So when I go back to my chart and I have this, I know a couple of things. I know that I know all the angles now. So I know that my alpha is going to be 86.38. I know that I solved my gamma, and that was 50.62. And then what we did is we subtracted 180 from this alpha, and we got that gamma is going to be 129.38. And when I added 129 and 43 and subtracted it from 180, I got that to be 7.617 degrees. So that's how you tie those in. You might have to watch this a couple of times to figure it out, but we're still not done. I know. This is the SSA case, if you know what I mean. Okay, so now going back over here, we still need to find A and we still need to find A prime, the side. So how are we going to do that? So the way that we're going to do that is we're going to take and do, okay, we're going to do the sine of 43 over 15 has to equal to the sine of alpha over A. And we stored alpha already, so we'll go back to that. And now we just need to know A. This alpha is the 86.38. So that's what we need to do. And so we do the cross multiplication and solve for A. So if we have that, A sine of 43 equals to 15 sine of alpha. And so A is going to be 15 sine of alpha over sine of 43. And so now I put that into my calculator with the alpha there. So let's see. Going back to the calculator, and when we put that in there, notice how the 86.38, I stored it in A. So we have 15 sine of A divided by sine of 43. So we have, we're going to do this, 15 sine of A. Okay, we have to put the parentheses. And then over, what was that? Sine of 43. So sine of 43. And we hit enter. And so we end up with the side to be 21.59. And so what you do here is you get A is equal to 21.95 centimeters. And so we fill in the chart for this to be 29.95. 29.9, so silly. 21.95 centimeters. Okay, and then to find alpha prime, there is no short way. You're going to have to do the law signs again. And so you're going to have to do the sine of 43 again, because that's the one that's always given. And the 15 is the opposite. That's never going to change on there. And now we're going to do the sine of alpha prime, which is this one right there. And we're going to put it all over a prime. So we already solved for alpha prime. So then you do the cross multiplication again, and you do the same math again on there, and we get A prime is going to be 2.92 centimeters, which makes sense that it should be smaller because it is actually smaller here. So this angle has to be bigger than this gamma and this gamma prime. This angle here has to be bigger than this alpha prime here. And the A has to be smaller on this one here. And that's how it all worked out. So this answer here is going to be 2.92 centimeters. That really doesn't show very well. Let's write it one more time. 2.92 centimeters. And that's how we solve the ambiguous case with two triangles. That is a lot of work. All right, but what happens in the other cases? So let's look at these problems right here. So if I look at this, in this case here, I have alpha, and then I have A. So I know that these are two opposites, and then I have another side. Since these two are opposites of each other, I know I have the case of side-side angle. And so what happens if I have 105? So I know that this angle is going to be obtuse because it's bigger than 90 degrees, and the opposite of that is going to be 7 inches, and then the adjacent, either one of them, it has to be, I'm going to just put it in here, the adjacent side is 10 inches. So if you can't visualize it, let's go back over here. Let's fill this in. So I know that this one here is going to be 10 and 7. So the opposite side is 7. This here is going to be 10. And then the angle was 105. And so this is what we have there. Let me get rid of that triangle there. And so we know that that's going to be obtuse. And this side, the opposite side, is just not going to reach the third side. So what we automatically know is it's an obtuse. There is no triangle. Notice how much easier this is. So this one here is no solution. We are done, no triangle. So we are done with that one. You do have to explain why, and I showed you why it was going to be on there, but you would have to explain in your own words there. Now, if I look at this, again, I got alpha and I got A. They're opposites of each other. We have another side, so it's the ambiguous case. So now I have to figure this out. So what's really going to happen? So I have 25, 4, and 12. So let's go look at what's happening here. And so I go over here. The opposite side was 4. Uh, let's see. 12 and 25. We know it's an acute angle, so we need to figure what is going on there. And so this is what it looks like. So I am going to have to figure out, if I notice it's not going to touch, and if I actually figure out what the height is going to be, using this formula, I get that to be 5.07. So this side, it is, the 4 is smaller than 5, so it's not going to reach it. So there is no triangle. So going back to this over here, we know it's not going to touch it. There is no triangle, no solution. And so we need to find the height. So the height is that you're going to drop this height down here, and that's your H. And so it's a right triangle. This here is going to be 25, and the adjacent side is 12. So the adjacent side here is going to be 12. So the way that you solve it is going to be sine of 25 has to equal to opposite over hypotenuse. So we end up with h, after you put this over 1, cross multiply, h is going to be 12, the adjacent side, times the sine of the angle. And then you know that it's going to be 5. So there is no triangle, there's no solution. That's what you need to explain by showing this work. And we are done with the examples.